Alright, so given below is the graph of a function f of x. State all of the conclusions that you can state about the graph of f prime of x, so the first derivative, and f double prime of x, the second derivative. Justify each of your conclusions. Alright, so I'm going to start listing stuff and you can help me finish out each statement. So the first one, we know that f of x, because this graph that we are given here for the first problem, this is the graph of f of x, okay? So f of x increases, and I'm going to abbreviate some so I have room. So f of x increases on the interval negative infinity to negative 4. So from here to here, it's increasing. And also from negative 2 to 1, it's also increasing right there. So, f prime of x is what at those points? On those intervals, the first derivative would be what? Exactly. Very good. Second one. F of x decreases on negative 4 to negative 2. So right here. Also from 1 to infinity. So it's decreasing there also. So f prime of x is what? Negative. All right. So far, not too bad. Let's look at this one. So f of x has horizontal tangents. At x equals negative 4, negative 2, and 1. So right here, and right here, they're horizontal tangents. So f prime of x would be equal to what at that point? So if you look at each one of those points, it's a horizontal tangent. That means it's flat. So the first derivative at those 3 points would be what? 0. Thank you. Alright, the next one. So what type of function is f of x? Linear, quadratic, cubic, quartic, quintic? What is it? If you're not sure, what would the power be? It's quartic, yeah, it's to the 4th power. So f of x is quartic. So f prime of x must be what? Cubic, exactly. So there's a lot of these. They're not too difficult. Some basic ideas that we've been using the entire lesson. Okay. Next one. F of x has maxes at x equals negative 4 and 1. So a max here and a max here. So f prime of x does what at those points? Okay, changes from what to what though? Yep, exactly. So f prime of x changes from positive to negative. All right, number 6. F of x has a min at x equals -2. So similar to above, f prime of x, first derivative, changes what? Stevie?
Positive.
Yeah, negative to positive. All right, number 7. F of x is concave up on -3 to -1/2. So from -3 to -1/2, we can see that the graph is concave up from those points. Okay, because from inflection point to inflection point, it's concave up. So what does that tell us about the first derivative? The original is concave up, so the first derivative is a little more challenging than before. Dan?
Should have a minimum.
The original has a minimum here,
Yeah,
but what is the
it's increasing.
derivative? Yeah, that's what the derivative is actually doing. F prime of x is increasing. So on that interval, the derivative is actually increasing. So if you look at the picture here, to maybe get a little better understanding of that, if you pick just one point on the original function, the derivative simplifies or represents what at a point? The slope of that tangent line. If I pick a point right here and I take a tangent line, the slope's going to be what? We don't know the actual number, but it will be negative. As I get closer and closer down here, it's going to be a negative number all the way until I touch the x-axis, but the negative number is getting closer and closer to what value? 0. Eventually, I get to 2. The slope is what? 0. Then I start going this direction. My tangent line is what? Positive. And as I continue, it's going to be a bigger and bigger positive number. So the first derivative is increasing that entire time. You're going from a negative, you get all the way to 0, and then you keep going up, so you're getting a positive value. So it's increasing that entire time. So that's why number 7 is true. All right, number 8. F of x is concave down from -infinity to -3, -1/2 to infinity. So f prime of x is what? So think about the one we just did. Decreasing. Now we have 2 more statements left, so I'll probably write them over here for the f prime of x side. We have 2 left. Then we don't have as many for the second derivative on this sheet, so you'll have some room. So I'm going to use this space down here for the last 2. So for number 9, f prime of x has a max at x equals -1/2 because f of x does what? Dan?
So Point of inflection.
Okay, which represents a what?
Change from concave up to concave down.
Exactly. Because f of x changes from concave up to concave down. Okay. Very good. And lastly, for this one, f prime of x has a min at x equals -3 because f of x does what again? Changes from concave down to concave up. So all 10 of those statements are all something we can say just from looking at that graph up above. We can determine what the first derivative is going to look like or some information about the second derivative just from looking at the original function. Are there any of those that you'd like to go back over? Okay with those? All right, so now we're going to look at the original function again, up above, but what it tells us about the second derivative. Okay, so the first thing, f of x is concave down on the intervals of -∞ to -3 and -1/2 to infinity. So from here to here and from here down. So those are the concave down sections. Those are the two sections we're talking about right now. So f double prime of x, the second derivative, would be what if those are both concave down? Remember, we talked about the second derivative test and we did some examples with the second derivative the past few days. So if the original is concave down, what do we know about the second derivative? Try to think about those tables we made. It's negative. Exactly. So if we talked about the concave down sections, what do you think we're going to talk about next? Exactly. So the f of x is concave up, and the interval is from -3 to -1/2. So f double prime of x is, talking about the concave up part now. So the second derivative is what? Positive. All right, I have two more statements left for this one. So number 3, f of x has points of inflection at x equals -3, -1/2, and those are the only two. Points of inflection happen where? Okay, between what though? That point is where the concavity changes. But you find it by doing what? Or looking where? I mean, you're right and correct in that, but there's another way to think about it. It's halfway between a max and a min. So we can see there's one there, and there'd be one there. And you told us it's where what happens? Concavity changes. Okay, so f of x has points of inflection. at x equals -3 and -1/2. So f double prime of x, the second derivative, does what at that point? Dan?
Equals 0? Or goes from positive to negative? Changes sign.
Yes, changes sign. That's what I'm looking for. Changes sign. All right, last one for this side. Since f of x is quartic, we talked about that before, it is quartic, f double prime of x must be what? The original is quartic. Yep, quadratic. How did you know that, or how do you know it's a quadratic?
Each derivative is down the power.
Each derivative reduces it by a power. So the first derivative, it becomes a cubic, and then the second derivative becomes a quadratic. Very good. So that's everything we were able to analyze just from looking at the graph of the function f of x. Okay? So that's all information you're able to find just from looking at the f of x graph. Any questions before we move? Yeah. Any other questions? All right, we'll go to the back. So now we're looking at the graph of the first derivative. So what they want us to do on the back now is state anything that we can tell about the original function or anything we can tell about the second derivative. And we're dealing with the first derivative. Okay? First one, f prime of x. So first derivative, f prime of x, changes from negative to positive at x equals -2 and at 3. So f of x has what? So we're talking about the first derivative graph right here at -2 and 3. Changes from a positive to a negative, so the original has to have what, Dan?
Wouldn't 1 also be a change? Oh, positive to negative.
Yeah, we're going from negative to
Okay.
positive right now. Yep.
Negative to positive, so f of x must have a minimum there.
Yeah, it's a minimum, exactly. Has a min. Number 2, we're going to talk about what Dan was headed towards. So f prime of x changes this time from positive to negative at x equals 1. So f of x has a what? Max, yeah. Alrighty, next one, number 3. The first derivative, f prime of x, is positive on the interval -2 to 1 and from 3 to infinity. So from -2 to 1 it's positive, and from -2, or from 3 to infinity, sorry, it is positive. So f of x is what? If it's positive here and positive here, this is the derivative. The original is what? Increasing, yeah. And if we talked about that, well, we're going to talk about whenever it's negative. So f prime of x is negative on negative infinity to negative 2 and 1 to 3, so those two intervals. So we can make the same conclusion we did from number 3, but this time it's negative, so the original must be decreasing. So for number 4, the intervals we were talking about were negative infinity to negative 2 and 1 to 3. Those are the intervals we were talking about. All right, number 5. F prime of x is cubic. So f of x is what? And I know we sort of talked about these already, but it's something that we can state from looking at this graph. F prime of x is cubic, so the original is what? Exactly. Very good. All right, number 6. The second derivative, f double prime of x, changes sign at x equals negative 1 and 2. So f of x has what? The second derivative changes sign at negative 1 and 2, so the original has to what?
Have a point of inflection.
Yeah. So we say the second derivative changes signs at those points. If you look at the first derivative, that point's right there. So the derivative, again, that would be positive, negative, so it's changing signs. But the original, if you go back a step to the original, that's where there's an inflection point. Yeah, so f of x has points of inflection. All right, number 7. We have 2 left for this side. F double prime of x is positive on the interval negative infinity to negative 1 and 2 to infinity. So f of x is what? Second derivative is positive on the interval negative infinity to 1 and 2 to positive infinity. So f of x is what again? Exactly, concave up. So think about that second derivative test we were doing when we made the chart. We had the intervals. We checked the number within that interval. If we checked the number within that interval on the second derivative, if it was positive, it was concave up. If it was negative, it was concave down. So that's what number 8's about. F double prime of x is negative on the interval negative 1 to 2. So f of x, just like number 7, but reversed, is concave down. All right, let's go over to the next column. So conclusions about the second derivative. f prime of x, the first derivative, is increasing on the intervals negative infinity to negative 1 and 2 to infinity. So we're talking about where this is increasing. This interval and this interval. So the two places it's increasing. So what do we know about the second derivative? So if we take another derivative on those two sections. Those are the two, talking about this interval and this interval. If we take the next derivative, what's going to happen? Yeah, if you put a tangent line on any point there, they're all positive, and a tangent line on them, they're all positive. So f double prime of x is positive. Number 2, again, is very similar to the first one, but we're going to talk about when it's decreasing. So f prime of x is decreasing on the intervals negative 1 to 2. So the second derivative is what? We're talking about this interval now.
Negative.
Exactly. Is negative. All right. Number 3, the first derivative, so f prime of x, has a max at x equals negative 1. So the second derivative does what? First derivative has a max at negative 1. So the second derivative is going to do what? My max is up here. Dan?
Change from a positive to negative.
All right, it changes from positive to negative, yeah. Very good. All right, 4 is similar to number 3, but we're talking about first derivative has a min at x equals 2. So now the second derivative changes from what to what? We're talking about the min now. Yes, thank you. Changes from negative to positive. All right, and last for this page, number 5. Last one for this page. F prime of x, so the first derivative is cubic. So the second derivative is what? Again, a little redundant. We've talked about it before, but this is still the conclusions we can make from looking at this graph. The first derivative is cubic, so the second derivative is quadratic. Very good. Any questions about this page? All right, let's go on to the last one. All right, so the last one, we're doing the same thing, but this time they give us the graph of the second derivative, and we have to state any conclusions that we can about the original and anything that we can state about the first derivative. All right, so first, the second derivative, f double prime of x, changes sign. Changes sign at x equals 0 and x equals 3. So, the original f of x what do we know about the original f of x? We know the second derivative is changing signs at 0 and 3. But what's happening on the original function at those points? Not quite.
Point of inflection?
Yeah, there's points of inflection there. So if it changes sign on the second derivative, on the original you have points of inflection. For the second one, f double prime of x is positive on 0 to 3. So 0 to 3 it's positive. And from 3 to infinity. So those are the two sections we're talking about. So the original is what? So think about your second derivative test. We're dealing with the second derivative right now. What does that tell us about the original? We know that we're positive on those two intervals. Exactly. Think about that table we created. When the second derivative was positive, it was concave up. 3 is going to be very similar. Second derivative is negative this time. From negative infinity to 0. So the original is what now? Concave down. Okay. One last statement for this side. So the second derivative is cubic. So f of x is what? Again, redundant again, but we're given this graph so we can tell about the original. We know the second derivative is cubic, so the original one is what? Stevie? We're not going derivative, we're going back now. This is the second derivative. What do we know about the original? You're doing the right process, but you did it backwards. Yes, exactly. So if you started your original function as a quadratic, your first derivative would then become linear. But we're going backwards. You're going from the second derivative and thinking backwards, so you got to go back twice, and you end up with the quintic. Very good. All right, on to the other side. So conclusions about the first derivative. So what we can find out about the first derivative from the second derivative. Does anybody remember about that relationship we mentioned when we started this section? What do we know about the second derivative related to the first derivative?
It's basically how the first derivative can be related to the second derivative, or that the second derivative is the derivative of the first derivative.
Close. You're sort of headed where I wanted to go. Did you have a different answer? So my question was, what can we say about the relationship of the second derivative to the first derivative?
The same as the first, the original?
Yes, that's what I wanted. It's the same as the first derivative is related to the original function. Okay? So that may have been what you meant, but I don't think you exactly said it in that way. Okay? So, if you get confused with the second derivative here, think about it as the first derivative relating it back to the original. Alright, so the second derivative of x is positive on the interval 0 to 3 and from 3 to infinity. It's positive on both of those intervals. So f prime of x is what? Again, if the second derivative, first derivative is confusing you, think about it as the first derivative related to the original. It's increasing, yes. We're going to deal with the same topic there. If the second derivative, f double prime of x, is negative on the interval negative infinity to 0, so we're talking about right here, it's negative, f prime of x is what? Decreasing. Very good. F double prime of x, second derivative, changes sign. So changes from negative to positive at x equals 0. So f prime of x has what? What can we say about it? The second derivative changes from a positive, or from a negative to a positive, sorry, at x equals 0. So the first derivative has what? Minimum. Yes, because we're going from negative to positive. Has a min. Okay, very good. Number 4, we're going to talk about the first derivative a little bit here first. So the first derivative, f prime of x, has points of inflection at x equals 1 and 3 because the second derivative does what? So what can we conclude? So you have the graph of the second derivative up there, but it says the first derivative has points of inflection at x equals 1 and 3 because the second derivative does what?
Has horizontal tangents there. It's like a max and a min.
If you go to, let's see, it's 1 and 3. Okay. There is a horizontal tangent there, so what's happening?
It's a maximum and a minimum. Or like, I want to say change of signs, but is that change of signs?
Well, I guess, let's see.
Because the graph of f double prime, it can't change signs.
Yeah, so at those points, I guess you would say, the second derivative at x equals 1 and 3, there would be a max at the 1 and a min at 3. Okay, so I misread what that one was saying. You are correct in saying that. So this one actually wasn't saying second derivative here. This was saying third derivative. So if you were to go one further derivative, what would happen with that third derivative?
Oh, then it would change.
That's where the change of sign comes from. So we haven't done any third derivatives, but if you were to take one more, that third derivative would change sign. Yes. Okay. All right, we have 2 left. So the second derivative, f double prime of x, is increasing. So I'm just going to put an arrow pointing up. It's increasing on negative infinity to 1 and 3 to positive infinity. It's increasing. So f prime of x is what? The second derivative is increasing on those two intervals. What do we know about the first derivative?
Concave up?
Yep. Exactly. Concave up. And 6 is going to be just like that same one, so we can go ahead and say the second derivative is decreasing on the interval 1 to 3. It's decreasing. So the first derivative is concave down. So I know there was a lot of writing packed into this today, but that is basically what you can look at a regular function, the first derivative and the second derivative of those functions, everything that you can analyze just from looking at the graph without actually having the function in front of you. Okay? So that'll be pretty important as we move forward.